Welcome, everyone. Thanks for joining the EA Global Summit 2020. This is Nizam from the organizing team, and with us we have Roman Hertz, the head of R&D at Cosmino AG. So Roman is going to talk to us about the value of modeling, in which he will elaborate and try to understand the mechanisms of modeling and why and when it's helpful, and finally, the actual value of modeling. Roman has several years of experience working with several clients in the space of modeling, and we thank you all for joining this session, and we thank Roman for taking time to do this presentation for us. Regarding questions for this session, please use our Teams channel to add any questions. The link to the Teams channel will be posted in the chat window as always. And if you have any difficulty joining the Teams channel, please do drop us a note here or through to our support channel, and we'll be adding you immediately. Thank you once again for joining, and we look for yet another presentation. Thanks, Roman, for your time. Over to you now.
Oh, thank you, Nizam, for the introduction. Hello, everybody. Welcome to my session. So, as Nizam already mentioned, I'm head of research and development at Cosmino AG. And my previous job was actually CTO at Level. Some of you probably will know. And in the past 10 years, I had a lot to do with modeling tools, modeling methodologies, etc. And the current session, I would call it a compilation of my experience over the past 10 years. I spent a lot of thoughts about modeling, why it can be valuable, and what is actually the value of modeling. So let's start. I will not talk today about numbers. I could, but it is also part of my experience that the numbers are very, they're always relative. It depends on so many factors, and it's individual for every company. So instead, I would like provide an inspiration, and I hope my presentation provides information for a deep understanding of the topic, will raise new discussions, and could become a starting point for developing new approaches and ideas around the understanding what is actually the value of modeling. Because I would assume most of you had this discussion in your organizations. So I would like to start with a story about an old man and an old watch. The father, before he died, said to his son, "Here is a watch I would like to give you. I got it from my grandfather, and it's more than 200 years old. But before I can give it, will give it to you, I'd like you to go to the first watch shop you find and ask how much they would offer for this watch." The son comes back a couple minutes later. He found the watch shop in the first street, and said to his father, "Actually, they offers me just $5 because the watch is old and it has a lot of scratches." The father asked the son to go to the next coffee shop and ask again, so what they would offer for the watch. The son come back and say again, "Yeah, they offer me also $5, father." Okay, then father asks the son one more time, "Could you please go to a museum and show the watch to them?" So the son is coming back 2 hours later, completely happy, and said, "Okay, they offered me $1 million for this piece." Okay, I would more realistic. Most probably they would have offered not an $1 million, but $10,000. But a huge difference between $5 and, I would, for example, say $10,000. Well, what is the moral of the story? That modeling belongs to the museum? Not really. Actually, the moral of the story is that if we want to understand the value, we need to understand the origin of the value, what it's coming from, where it's coming from, and understand the stakeholders. Who are the stakeholders of modeling? So let's start. And what we will talk about today, so actually about the subject of our interest, modeling, its value, analysis and synthesis as a method, discussing and verifying concepts, evolution of concepts, providing access to information and knowledge, and about a little bit about code generation. So let's start with a model. What is a model? I read a lot of definitions, and I do not like completely most of them. A typical definition of a model sounds like this. It's an abstract representation of reality. Why I don't like it that much? Because it's actually describes nothing. It says, okay, it's more abstract than reality. But what does it exactly mean? What it is more abstract? Okay, less details, but what details we can skip? And yeah, this abstraction mechanism, how it works, it's not that simple. You can assume what it could mean, but what means concretely? And the other thing is, the other issue, okay, it's the representation of reality. But if we're going to build something, the reality does not exist yet. So it represents something it doesn't exist yet. So I found finally a definition which I like more, but it also doesn't cover all the aspects of modeling, in my opinion. We will talk about it later a little bit more in detail. So, but back to the definition I like. Model is a system on its own, which is studied to obtain information about another system. So we built a system to study another system, which is existing, so reality. The other system could exist in reality, or the system we will build in the future. So, and model, of course, it representation of reality or desired reality, and it could be in different representations. It's not necessarily must be not necessarily graphical. Typically, in our case, it's graphical representation, but it could be also mathematical representation or descriptive representation. And it's designed to represent just certain aspects of reality or of another system, and should allow us to answer questions of our study. Well, so, and why I like it? Because as I read this definition, it was clear to me a model is a system on its own, and we use it to study something we're going to build. Well, but as I already mentioned, it doesn't necessarily covers all the aspects of modeling. Well, A model should also have some qualities, some reasonable qualities. So just to introduce what it is, what the subject of our interest is, modeling, or model, what we are talking about. The model should be adequate. It should be conform to the real system, to the real world. But it should consider actually only the most important qualities, connections or characteristics. And of course, it's very difficult to decide at the beginning what is actually most important, especially if we build a new system. And in such a situation, only what we can use is our experience from previous modeling projects. It should be accurate. It means the degree of matching so if we are working with our model, if we are studying our model, and we're obtaining some information from, we're learning from our model, this information, what we learn from our model, should match the real desired system qualities. It should be universal. It doesn't mean that we should desire to build a model which is universal for everything. Not at all, but it should be universal for several similar systems and different modes of operations of our system. So we can build some general insights. So it must not be too specific. So, and of course it must be cost effective. And the cost effectiveness can be achieved, and it's actually typically a result of compromise between the resources, time you invest, and the model capabilities you build. So we introduced the model, and so what it is. And now we want to analyze, okay, what is the value of those models? And yeah, I spent a lot of time to figure out what would be the best presentation or what would be the best methods how to figure out what the value is. And finally, I came to the conclusion, actually, in the modeling, we have methods which provides actually which allows us to figure out the value. And it's use case diagrams. So I used modeling approach to understand modeling better. My thesis is that there are only 4 use cases of modeling, no more. This is a thesis. We could discuss about it. I would happy to discuss if you could find more. I wasn't able to find more. Of course, the more detailed different aspects, but the main use cases, I found just 4. First, it's analysis and synthesis. Actually, this is what you're doing if you're starting to think about a problem you want to solve, you want to build a solution, and you start with an analysis of requirements, analysis of a problem, and then at the end you build a solution. You synthesize something new. It's a core activity of an architect, software system, whatever architect or engineer, or climate engineer as well. And modeling definitely can help here. Then next use case, discuss and verify concepts. It means we use very often models to communicate. We communicate some concepts, some ideas. The engineering department discussing and verifying its concept with the customer. So we could create use case diagrams, we can create process diagrams, and we can discuss using these diagrams
Roman, we have some trouble with your audio. Are you okay with your audio? So just give us 1 minute. Roman is just fixing his audio. He's back now.
So where should I?
Roman, sorry, we lost you for a few minutes. Your audio was, you were not audible for the last few minutes. So you might have to just go back from the start of the slide. Thanks.
Just with the slide?
Yes, just this slide. Yes, thanks.
Okay. Good. I hope it will work better. Just okay. So let's repeat. So my idea was, as I decided to figure out what is the value of modeling, I spent a lot of time to figure out what are the best method to do it. And I don't know why I didn't come to the idea from the very beginning to use case diagrams, but at the end it was clear. So it makes sense to use modeling approach, in that case, use case analysis, to understand the value of modeling as well. So, so we use modeling approach, one of the modeling methods, to understand the value of modeling. Well, so, and at the end, I came to the conclusion that there are just 4 use cases for modeling, not more. This is my thesis. You can argue with me, so we can discuss it. I would like to discuss it. If you are able to find more than 4, or you will call them different, this is my current understanding. I cannot find more than 4. So let's start to go through. So the first one is analysis and synthesis. So analysis and synthesis methods we actually use on daily basis. Every engineer is using that. So if you want to solve a problem, if you want to solve build a solution, you always start with analysis of a solution, of the problem, of the requirements, and at the end you're synthesizing something new, your solution, your product, your system. Yeah, and requirements engineer are doing requirements analysis, software system architect, solution architects building new systems, and so on. I think it's clear. So then we have The next one is discussing verified concepts. So we're using models or modeling approach to communicate, to discuss, to communicate the concept, to discuss the concept, to verify the concept. It could be a requirement engineer or product owner who is creating process diagrams, activity diagrams, or use case diagrams, and discuss them with the customers. On the other hand, it could be an architect, software architect, system architect, who is creating a model and communicating the concept of architecture to the developers. And it's also not on the one-way direction. It's actually also in that case, it should be discussion. And the software architect or system architect should verify if it's suitable, if it's reasonable, if it will work. And the developers should provide feedback based on these diagrams, based on this model. Well, then generate code. At the beginning, I skipped this one, but at the end, I came to the conclusion it is not covered by any other of these use cases. It's a separate use case. Yeah, I think it's most probably it's more or less clear. We have built a model and generate code, which can be compiled and or interpreted directly by the system or by execution environment. So, and the last one, provide access to knowledge. This is, from my point of view, it's more new and a new one, because in the past, what I have observed, it was typically used, the first three use cases were using or playing and building a repository which contained the model and provide access to this repository to everybody, to every possible model consumer. It's actually something new, or last decade became more critical and more interesting for the organization. And for example, Collaborate is going definitely to the direction, by the way. Well, good. And now let's go into more details. By the way, so I already presented these use cases to another audience, and I got a question: what about simulation? If simulation is an additional use case, and in my opinion, not. It is not, because simulation it brings an added value to any other use case we have already discussed, but it's not valuable on its own. It needs context, and it's provide a short feedback loop so you can learn better. Well, good. Let's continue. Analysis and synthesis. As I already mentioned, so if we start to build something new, we got a lot of information, very often unstructured information, many facts, many assumptions, and about something we need to build. So, and first step we're splitting it. We decompose this complex thing into the most elementary parts. And then we're starting the elementary parts on their own, the properties functions in isolation. And then we describe the object of interest as a sum of properties and functions of its parts. Actually, this method is very often used in the science. It's actually the basis for science. So, and if we are done the analysis, we build. So using the knowledge we gained, we use it, and we start to use the parts we have created and compose them. The qualities, properties, relations, and yeah, we build a concrete system, something new. And at the end, we should be able to recreate the general desired properties of the whole thing we want to build using the parts we have introduced. This is analysis and synthesis. So how does it apply to modeling? I mean, there are so many examples. I just put here few of them. So requirement analysis. We derive system requirements from customer requirements. So we analyze customer requirements and introduce small pieces system requirements. But then we split system requirements into subsystem requirements and so on until the lowest level has been reached. And then actually we analyze the every particular requirement on its own in isolation. So the requirements should be, as you know, encapsulated, they should be testable, they should be consistent, etc., etc. So for system decomposition, we split the architecture. Actually, what it is about, it's also about the composition of a desired system. So we introduce subsystems, components, services. We define their properties, qualities, interfaces in between, etc. Or if we're doing a process analysis, or if we're using activity diagrams and we define how the customer will work in the future, we split the whole process in a particular steps, activities, and describe how the path is looking. So what we're doing first, what we're doing then, if, then, else, etc., etc. It's nothing else than pure analysis. And many activities of an architect are about synthesis. For example, IBD system, SYSMOD diagrams. We have introduced the components and then we use them and build a system, compose them to build the whole system at the end. So, but if we would just use the analysis only, there is an issue because if we focus on the parts only, the relations we are not thinking about the relations between those parts. And if the introduced parts during the analysis, or if our system is not that much interconnected to the rest of the world, then it's not that critical. But if we are building a complex technical systems, or we are working with ecosystems or complex networks or social systems, we need another method. So because there we are talking primarily, or at least the relations between the elements are that important as the element themselves. And a very concrete example, so the safety of the system, it's a global property. It cannot be reached just by combination of safe components. So safety, it's something, safe system, this property, it's something which is not component specific, it's a system specific. And in that case, analysis by synthesis is required. Actually, this is something we are using also on a daily basis. Just another picture to explain the limitation of analysis. So if we had analysis and synthesis on their own, so if we, for example, would like build a house, the end we have models like this, so 3D model, 2D model, water heating, electrical views, etc., etc. But what we will miss then is the context of the system we want to build. The house is not existing just on its own. It's embedded in the environment and the context. Transportation systems, energy, city, communication, and the whole world is around us. And so if we build a house, we must consider the context as well. Well, analysis by synthesis. Actually, it has been introduced or described in the psychology at the beginning, but as I already mentioned, it's not something special. It's what every engineer is using on a daily basis. To build something new, we often imagine it how it will work in a certain environment or in a certain context. So for example, like on this picture, if we want to figure out as an object is fragile or not, we put it in the certain context, like on the picture, and perform then the experiment mentally or in real, and see, okay, what will happen under certain conditions. And we will come to the conclusion, okay, it's actually fragile. And if we want to save it from breaking, we need a solution for that. In terms of modeling, actually, I'm talking about context diagrams or introduction. For example, SYSMOD or in SYSML, we would introduce a system context, a separate element, and put then our system in the system context and figure out what requirements we should derive from that point of view. What qualities the system should have, what interfaces to the rest of the world it should have into this context. Well, the next use case. Discussing and verifying concepts. If you want to share, discuss, or verify your ideas, you need a language. It doesn't work without language. In particular, in our case, we are talking about the modeling language. But in general, the first question I ask myself, okay, why human language has been developed by nature? What is the reason? What is the value from the evolution point of view of a human language? What advantages we got over other species? This is not trivial question. The first answer probably will provide the language is required for communication, the general communication. But I wonder if it's true. Why? Because animals can also communicate. Their basic language is typically sufficient to perform all the activities they have to perform. Hunt, eat, having relationships, etc., etc. It works without human language. Why such a complex thing? And this is another thesis of mine, of mine. Okay, one more point in between. So the language, so the modeling language, if I ask people why we need a modeling language, very often I got the answer, okay, because it's more abstract than human language, for example. And we all already talked about the model itself. It's an abstract representation of the reality, but how it works, where is this abstraction level coming from? And I came to the conclusion actually that it is about the concepts realized by a certain language. Just take some artificial languages we have created, assembler. So what concepts are realized by assembler? It's concept of symbolic names, jumps, loops, a few of concepts. And then came C, for example, has been developed, and it brought new concepts, struct, operations, variables, switch cases. It's more complex that the concept has been implemented by assembler. And C++ brought even more complex things, inheritance, polymorphisms, exceptions, encapsulation. And the UML or SysML or BPMN, depends on the language, modeling language we are talking about, definitely brings even more complex concepts which are built in the language. And this decides about the abstraction level. What I mean by concepts built in the language. If for example, let's take state machines as an example, or components, or interface, whatever you want, but I like state machines very much. Why? Because if I talk to somebody about state machines, I just need one word or two words, state machine, and the opposite side, my counterpart, understands what I'm talking about. But how? Because the person has learned the concept before we started to talk. So if you want to know what a state machine is, you can read a book. There are books just about state machines. So it could be a very complex term, very complex concept, or component-based design, or what is an activity, activity diagrams, how it's working. It's very complex concepts. But if we learn it once and we have a word for this concept, we can communicate very fast. And so it means in the end, if we want to talk about something, we need a word for this. Then we can start to talk and to think about it. And this is my thesis, the reason why we developed a human language, because we needed a possibility to build very fast new concept, learn new things, adapt ourselves to our environment. And yeah, I believe also that UML is still alive because it supports profiles mechanism and can be adapted for a very specific domain or problem. So at the end, what I wanted to say, the human language, and at the end, a modeling language, is the result of evolution. And it brings on its own advantages, value. As this evolution has started, the evolution worked on the hardware level. Its new features of creatures has been developed over time. It started with cells, and then plants and animals has been developed. So, and it took very long time. Then a new mechanism have been created. A brain. Brain was able to learn during the lifetime of one species. So we started evolution at the software level. We call it learning. We a species, as a person, an animal can learn during its lifetime and adapt himself to the environment. But later came a new step. Evolution. It should be evolution of ideas in a crowd. So if we put 5 people in this room and say to them, okay, do this brainstorm about a problem, they will come to the solution faster than one person. So 5 days, 5 people within 1 day will reach definitely more than one person in 5 days. So the language actually is a mechanism, is a tool to develop new ideas using more resources. It's not your thinking, personal thinking process. You're communicating with other people and you develop new concepts. And you're doing it by introducing new words, discussing it, developing it, etc. And the last step, actually, it was the science. Science was a driver of evolution of ideas. You can definitely see what societies or what countries, what regions increase its performance, definitely as they focus on the science, on the scientific method. So, and yeah, and on the bottom you can see evolution of idea of voting and democracy. Yeah, it's also an evolution, and it has been developed over hundreds of years by many people. Yeah, and what is a scientific method? You will actually recognize it. It's everybody knows. So you make an observation, form a hypothesis. Yeah, you need words for this. Perform the experiments, analyze the data, and then report the findings. Again, you need the language. And at the end, invite a new person, your colleagues, to reproduce the results. And this is actually what we should do, what we can do, and what we should do using modeling. Yeah, and within using Enterprise Architect, we could create new terms using MDG technologies or UML profiles, and even increase the abstraction level of an existing modeling language, creating new ideas, etc., or just using use case diagram like I did. So if you think at the beginning of my use case diagram, what is a use case for the modeling? I introduced a new idea and I communicated using modeling, use case diagram, and I would like to discuss it with you. And together we would be able to even reach better results. Let's over jump it. So code generation. I will not spend too much time on that. It's a very complex and big topic. But what is the value of the code generation, and if it's provable or not? I actually coming from Soviet Union, and that's the reason why I can read Russian articles in the internet. So yeah, in the Soviet Union, we had a lack of resources very often, and also lack of resources of programming of people who were able to program complex systems using assembler, for example. And if you hope you're aware about this space shuttle, Russian space shuttle program called run, and it was fully automatic system. So it was it flight just once, but fully automatic. And it was able to, at the end, actually, while landing, as you can see in this picture, the space shuttle, it just should land just straight. But the complete team was shocked as they realized that space shuttle changed its route, and they sort of assumed that it will crash. But instead, the system has calculated a better approach to land, and it's landed safely. And the analysis of this behavior of the space shuttle, the result was that it was the best, actually the best possible solution how to land safely. Yeah, and whatever. Due to the lack of resources, Soviet Union needed approach how to develop the software in a very short time. And what happened, they developed a new languages, also modeling languages at the end. And it has been used also later for developing international sea launch platform, and et cetera, many products, future products, and it's using until today. So, and it's a proof, if you have no other chance, you use modeling and you use code generation. But it's not used very often, not always. Why? Because it's actually also a question of tools. And I see it in that way. The majority of people who's working with modeling tools, they use model repositories like a drawing storage. Couple of them used built traceability within the model repositories, and just few percentage is doing code generation. Yeah, and why? Because it's not, the process is not that easy. If you would compare the modern IDEs to develop source code, they're more comfortable, and the velocity of typing code is much higher. And I hope the tools for modeling and actually really from developing source code, generation of source code, would improve in the future. Then we could gain even more advantage from this approach. Well, the last one, provide access to knowledge. First of all, we need to answer the question, what is knowledge? And I found that definition, it must not be completely settled down concept or definition, but I like it because it's I can use it, at least for me, to understand what is knowledge. It's so-called DIKW pyramid. And at the beginning, we have data. It's discrete facts, measurements. It's not interpreted, so it's just heap of data. To gain information from the data, we need to calculate it, categorize it, condense it, correlate it, organize it. So we can interpret this data. If we interpret it, data is information. And the knowledge comes only if you put the information in a certain context. Like you see on the right, if we take some information, some data, and without context, and if you would find something like a book in a space, it's meaningless. You cannot use it. You don't know anything about the context. So it's not the knowledge. Knowledge requires context. And how big the value of could be of providing access to the knowledge or even to the information. You can see it if you look at Google, one of the biggest companies in the world, and its vision, it's very simple. Organize the world's information, makes it universally accessible and usable. You can take it and implement it in your company. And could be as successful as Google within the organization if you do your job right. And about doing right things versus doing things right, there is another aspect of this concept, the IKW. So again, you have data at the beginning, we have information, knowledge, and understanding. By understanding, we gain wisdom. So here we're doing right things. And if we did right things, if we built our model and provided the access to everybody, then we could start doing the right things. Actually build our system. And if information is, when information is useful, we can take it to opposite criteria. When it's not useful, if the information is not consistent or it's not true, then it's garbage. When it's not true, if it's not up to date or not consistent. So we need to ensure that the information in the model is up to date and it's consistent. And the model repositories make it possible to ensure the consistency of our knowledge, of our data, of our information. And model repositories allows us to avoid redundancy, because redundancy is a poison of consistency. If we could avoid redundancy, then it makes our task ensure consistency and ensure that information is up to date much easier. And the model repository increases the chance that it's what you have created is not data, but information. Maybe it is knowledge, because it's put in the context, it's interconnected, and actually it's about traceability within the model. Then you can make use of it and start doing right things in the organization. Well, I think that's it. We have reached the end of the presentation.
Thanks.
Thank you for your attention. I hope
Roman.
the quality was good enough. And I'll be happy to answer the questions if you have any.
Yeah, thank you, Roman. It was a very interesting presentation indeed, and there's a lot of interest to check if you'll be sharing your slides. It's a very well put together slide. So there's a few questions and few interest to see if you'll be sharing your slides.
Yes, sure. I will provide an PDF compilation of slides, and make it available most probably in the Teams.
Okay, that is great. We have added that question in the Teams as well, and we have got a few more questions. It's more than question; it's more like a discussion. Maybe if you would make yourself available in Teams after this, it will be really good. But we have a few minutes. What I'll do, I'll try to share my screen with the Teams open, so that you'll be able to see what kind of discussions are happening, and then you can try to provide a detailed response when in the Teams itself. So you could see there are are you able to see my screen? I guess
Yes,
everyone should be able to see my screen.
I can see it.
So one has said the model can also be used to communicate with commercial stakeholder needs of the business to the modeling and design teams.
Sure. Yeah, it's about communicating concepts. I mean, whatever concept is, it's commercial needs, business needs, etc., etc.
Okay, so maybe
in my opinion, it's covered by one of the use cases. Sure.
Yep. So there's also Jerry mentioning about another use case and some details going on as well. So I guess these are the kind of discussions we would really like to have and continue. So after this session, if you are available in the Teams, it'll be really good. It will also be very useful for all other practitioners who are joining here.
Mm-hmm.
So there's another question from Martin, which is, how do you think modeling can reduce testing in real world?
Yeah, I think it's about doing right things. You need knowledge first. You need to build in knowledge. And if you have this knowledge, you can figure out what are the right things, what are the right tests you have to do. It's a rough answer. I mean, it sounds very abstract, but if I refer to the use cases I have introduced, actually, first of all, you need to build your knowledge in your model, in your model repository. And of course, the first use case, analysis. You need to split your input into atomic pieces and study every atomic piece separately, and then build things together. And then if you've done this job, if you have it, then you have the input, and you have the knowledge about what tests are necessary and what tests could be skipped.
Okay, thanks, Roman. And there are quite a few other discussions popping up as we are talking. I guess it'd be good if you have a few minutes to spare in the Teams after this session for having some discussions with us. And thank you everyone for joining this session. So even any other discussions that you want to ask Roman, please do feel free to ask in the Teams channel. And even if not immediately now, we'll make sure we'll have some kind of interaction happening during the summit.
Yeah. Just I take the chance to mention one more time. So why collaborate, for example, could be important for your organization. Share your knowledge and allow to discuss about concept available in the model through your organization. Not only the people are using Enterprise Architect are able to do this, but also everybody who can access to a web browser can access to the knowledge built in the model repository. Okay, I mean there are many tools, also Lemon Tree, we have been built. I have been built in my previous company at Liber. It's also useful, but from this use case point of view, provide access to information, to the knowledge, and enable communication within the team on model, using model. Such tools as web access, Prolaborate in our case, or using Git for accessing, product accessing. Those are tools which are improves your capabilities in terms of modeling.
Yeah, thanks, Roman. I think there are quite a few suggestions and pointers along the same lines. Like even Jerry has said, having the information in the modeling tool helps team communicate across countries for geographically distributed teams. So I guess, it kind of boils down to modeling and communicating the knowledge to the wider users. And you presented some excellent use cases for modeling and the real-time example of even getting it to the code generation is really exemplary. This is a very useful presentation, and thank you on behalf of the entire team and all the registrants for doing such a wonderful presentation. And we also thank all attendees for taking time to attend this session. We look forward to see you in the next session and also in the Teams channel for having more discussions or have any questions for Roman.
Thank you from my side. Thanks a lot for very good organization.
Thank you.
And yeah, I will be available in the Teams at least next hour or so, and then let's see. Good. Bye-bye. Thank you for your attention.